On the last day of 2019, several unusual cases of pneumonia appeared near a wet market in Wuhan, China. This was the beginning of COVID-19, a disease caused by a coronavirus that now has the world scrambling to find its cure. In the panic to end the virus before it ends us, fear and false information surrounding the virus has spread throughout the world, leading to widespread misunderstanding. If people don't know why they should take the coronavirus seriously, humanity will face detrimental consequences.
View this the same as the flu. It's going to disappear. One day it's like a miracle. It will disappear.
In a difficult time like this, it is essential that people are educated about the coronavirus such that we can minimize the damage done. To help you understand the coronavirus, I'm here to break down the science behind COVID-19. COVID-19 is the respiratory disease caused by SARS-CoV-2, a novel type of coronavirus. Don't be afraid because coronaviruses aren't new. Humans have a long history with different types of coronaviruses, from the ones that caused the 2003 outbreaks of SARS to the numerous MERS outbreaks. In fact, it's likely that you've been infected by a coronavirus at least once before. Ever catch a cold? 30% of colds are caused by coronaviruses. Similar to other coronaviruses, the main way of spreading SARS-CoV-2 is through droplet infection, which means contracting the virus by touching the saliva or discharge of someone infected when they cough or sneeze. However, the virus can also transmit through surfaces. Studies show that the coronavirus can remain infectious on cardboard for up to 24 hours and on plastic and stainless steel for up to 3 days. This is why we must wash our hands frequently, as we like to touch many things daily, one of which is our face. If you are infected, there is an incubation period of 1 to 14 days in which you show no symptoms. This is an issue since the virus is still contagious, and if you don't know you have it, it easily spreads to other people. In nearly all cases, SARS-CoV-2 is contracted through the openings on your face and begins its infiltration through the top of your throat. At this stage, around 80 to 85% of patients are able to eradicate it here. However, if it does spread further down to the lungs, things start getting serious. Like all coronaviruses, SARS-CoV-2 is some genetic material protected by a shell that has spiked proteins around it. Once inside the body, the virus uses its spiked proteins to latch onto the cells in our lungs, connecting to the cell receptors. These proteins act as keys that unlock the cell membrane, allowing them to invade by inserting its genetic material, which is RNA, inside of the cell. This then hijacks the cell's internal machinery to produce many more copies of the virus until it kills the cell. Your body reacts to this by calling in the immune system, our natural defense. But this is when the real problem starts, as the viruses begin to infect the immune cells. The infected immune cells overreact and call in more immune cells, infecting them in the process. They kill not only your lungs' infected cells, but also your healthy tissue, creating even more debris and causing pneumonia. If the protective epithelial cells that line your organs are damaged, bacteria that were previously stopped by the lining are now able to infiltrate your lungs, damaging the alveoli that allow oxygen to enter your bloodstream. This damage to the lung makes the tissues much more water permeable, releasing fluids into the lungs, filling it up and depriving you of oxygen. This can cause people's lives to depend on ventilators or even experience complete respiratory failure. Usually, deaths from COVID-19 are caused by the ventilators being unable to give the patient oxygen because there is simply too much liquid. This is why hospitals are rushing to receive more ventilators such that they can continue to support those who are at this stage. If people do manage to recover, it sometimes comes at the cost of permanent lung damage. Why is it so hard to cure COVID-19? COVID-19 is hard to cure because unlike bacterial infections, antibiotics do nothing against viruses. Most prescriptions for viral infections simply fight off symptoms until your immune system finds a way to overcome these tiny intruders, so it actually doesn't cure the virus. Few infections actually have an antiviral medicine to treat it, since it's very difficult to find something that stops the virus and doesn't hurt the cell. Additionally, coronavirus mutates and adapts extremely quickly, making treatments ineffective to some strains. That's why viruses are generally prevented rather than treated through vaccines. Vaccines allow your immune system to have a practice round against the virus. So after fighting off the germ once, your body will remember what substances it should use when it's invaded again. How are scientists currently trying to cure COVID? Scientists are using many different methods to fight back. The first method is through attacking the virus's own proteins, preventing them from doing things like entering a cell or copying their genetic material. This is how remdesivir works. It blocks the coronavirus from copying its RNA, or genetic material, and the instructions it uses to replicate itself. This is also safe as it only affects the virus and not our cells. The second way is by blocking a viral protein from interacting with a human protein it needs. This approach will protect the host and has a big advantage over disabling the virus itself. Currently, scientists have created a list of human proteins which the virus relies on, and are looking into pre-existing drugs which might be able to fight the coronavirus. Taking inspiration from the 2003 SARS outbreak, scientists are looking into chloroquine and hydroxychloroquine, anti-malarial drugs that help with treating SARS. Research, however, has shown that while it does help greatly with pneumonia, it does not stop COVID-19 and only treats the symptom. Another promising method is through protease inhibitors, a type of antiviral drugs used to treat HIV. Protease inhibitors work by stopping the virus from maturing properly, disarming its ability to spread. Lastly, a future vaccine could help our bodies produce antibodies which target the SARS-CoV-2 virus and prevent it from infecting human cells. It would work similarly to the flu vaccine and help in the prevention of infection of humans.
It means avoiding groups. It means staying home as much as possible.
新型コロナウイルスが
That's why we've been asking people to stay at home during this pandemic.
So please stay
then
at home.
huge
If you
numbers
don't,
are
the health
compliant.
system
And
will
I
collapse.
Social distancing.
L'épidémie de Covid-19 était peut-être...
人员流动性激增。